A boat can travel with a speed of 13 kilometers per hour in still water. If the speed of the stream is 4 kilometers per hour, what is the time taken by the boat to go 68 kilometers downstream? So the boat can travel with a speed of 13 kilometers per hour in still water. So this is actually the speed of boat in still water, that's S. Now if the speed of stream is 4 kilometers per hour, so S stream is 4 kilometers per hour. Now with these two data that we have, we can calculate the downstream speed, which is equals to the addition of the speed of the boat in still water and the speed of the stream. So that's equals to 13 plus 4, and that is 17 kilometers per hour. Now this is the speed, this is the distance, we want time. So time is equals to distance upon speed. It is equals to the distance is 68, the speed is 17. 17 times 4 is 16. So 4 hours is the time taken to go downstream. Option C. A boat covers a certain distance downstream in 1 hour, while it comes back in 1.5 hours. If the speed of the stream be 3 kilometers per hour, what is the speed of the boat in still water? First of all, let us consider that the speed of boat in still water be x kilometers per hour. So S is equals to x kilometers per hour. Now upstream speed is actually equals to the speed of the boat in still water minus the speed of stream. So that's the speed of boat in still water is x minus the speed of stream is 3 kilometers per hour. So x minus 3. Now what is the downstream speed? So it is equals to the speed of the boat in still water plus the speed of stream. So that's x plus 3. So we have these two quantities, speed upstreams and the speed downstreams, as x minus 3 and x plus 3 respectively. Now it is given that the boat covers a certain distance upstream as well as downstream. So the upstream distance is equal to the downstream distance. Now upstream distance is equal to upstream speed times the time it takes to upstream. So it is x minus 3 times the time it takes to upstream is 1.5 hours. That's 3 by 2 is equal to downstream distance is equal to the downstream speed times the time it takes to come downstream. That's 1 hour. So x plus 3 times 1. So I have 3x minus 9 is equals to 2x plus 6. So 3x minus 2x is x is equals to 9 plus 6, and that's 15. So the speed of the boat in still water will be equals to 15 kilometers per hour, and that's option D. A motorboat whose speed is 15 kilometers per hour in still water goes 30 kilometers downstreams and comes back in a total of 4 hours 30 minutes. What is the speed of the stream? Now let the speed of the stream be x kilometers per hour. So this downstream speed will be equal to the addition of the speed of the stream and the speed of the boat in still water, and that's 15 plus x kilometers per hour. Now the upstream speed will be the speed of the boat in still water, that is 15, minus the speed of the stream, minus x. So we have the downstream speed and the upstream speed. Now it is given that the total time taken to go downstream and come back 30 kilometers is 4 hours 30 minutes. Right, that's 4.5 hours. So 4.5 hours is actually the time taken to go downstream plus the time taken to come upstreams, isn't it? So the time taken to go downstreams is actually the distance upon speed. So the distance is 30 upon the downstream speed, and that's 15 plus x. Plus again the time taken to come upstreams or go upstreams is basically the distance, that's 30, divided by the upstream speed, that's 15 minus x. And when you'll solve this equation, you'll get the value of x as 5. So the speed of the stream is 5 kilometers per hour. Option B. A boat takes 90 minutes less to travel 36 miles downstream than to travel the same distance upstream. If the speed of the boat in still water is 10 miles per hour, what is the speed of the stream? Now let us consider that the speed of the stream be x kilometers per hour. Now we can calculate the upstream speed. The upstream speed is the speed in still water minus the speed of the stream. The speed in still water is 10 miles per hour, so 10 minus the speed of the stream is x, so minus x. And similarly, the downstream speed is equals to the speed in still water, 10 plus the speed of the stream, plus x. So we have the upstream speed and the downstream speed. Now it is said that the boat takes 90 minutes less to travel downstream than to travel the same distance upstream. So we have the time taken to travel downstream is equals to 90 minutes less than the time taken to travel upstream. So TU minus 90 minutes. 90 minutes is actually 90 by 60 hours because we are taking everything in hours. So we have the time taken to travel downstream is distance upon speed downstreams, right? The distance is 36 upon speed downstreams is 10 plus x. It is equals to TU is 36 by upstream speed, that's 10 minus x, minus 3 by 2. So you have 3 by 2 is equal to 36 is common. You have 1 by 10 minus x minus 1 by 10 plus x. And let me solve this for you. On solving this, you'll get a quadratic equation which when you solve it further, you'll get two values of x. One of them will be minus 50 and the other will be 2. And you always ignore the negative value because speed cannot be negative. So you take the value of x as 2. So 2 kilometers per hour is the speed of the stream. So option A is the correct answer.